Okay, this lesson is on solving polynomials once again, though in these cases you're going to end up with complex solutions, or solutions that involve an I. So the methods used in this lesson as related to the previous lesson are exactly the same. The only difference is in this lesson you're going to see what happens when you get I in your answer. So the process is exactly the same in the sense that you plug this into your graphing calculator and see if you can find one of your solutions. If you plug x to the fourth minus 5x squared minus 36 equals, well, not the equals 0 part, but if you plug in your graphing calculator and hit graph, you can visually see, sometimes you can visually see your solutions. Other times you may need to look at your table to verify your answers. And I've already done that, and it looks like that 3 is one of my whole number answers. So I'm going to use 3 in synthetic division to simplify this problem. Now it does skip a few here, like the x to the third and the x. And I run synthetic division here. 1 comes down, 1 times 3 is 3, 0 and 3 is 3, 3 times 3 is 9, negative 5 and 9 is 4, 4 times 3 is 12, 0 and, 36. 0 and 12 is 12, 12 times 3 is 36, and voila, 0 at the end. So I know I did that right. So what happens is I end up, since I had an x to the first, or x to the fourth, it's now going to be x to the third. So my new answer is x to the third plus 3x squared plus 4x plus 12. Now, if you remember from what we did in the last lesson, I have a cubic with 4 terms. So I have to use grouping in order to solve this problem. So I'm going to use grouping. Group, 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 group. I take out an x squared, which leaves me with x plus 3. I take out a 4, which leaves me with x plus 3. I know I did this right because my factors are the same. You pull your GCFs into one single parenthesis, so x squared plus 4, and the common factor of x plus 3 in the other. Now we are solving, so I do need to set these equal to 0, so I have x squared plus 4 equals 0, x plus 3 equals 0. Now, when I set the first one equal to 0 and I subtract, if I move the 4 over here, I get x squared equals negative 4. So I square root both sides, and you can see how you might get an imaginary solution here because I have negative in the radical. So if you remember what happens, you place an I out front, so this becomes x equals plus or minus I radical 4. But we know radical 4, we know the square root of 4. The I made it a positive 4, and the square root of 4 is 2, so this just becomes x equals plus or minus 2i. There you go. And the other solution when I move the 3 over is x equals negative 3. And there are my 4 solutions. Since it was x to the fourth, right there, I have 4 solutions, 3 plus or minus 2i and negative 3. So that's really it. It's not anything too crazy complicated. You have 4 solutions, so you should get 4 solutions. The problem is when I looked at my graph, I only saw 2 parts that cross the x-axis. That's one thing to understand too, is looking at the graph itself. When I should have 4 solutions and I pull open the graph and I only see 2 times that it crosses the x-axis, I know I'm going to have complex solutions. If there's 4 solutions and I only see 2 x-intercepts, that means only 2 of my solutions are real. The other 2 must be imaginary, and that was verified here with this answer here. 2 of them were imaginary. Let's do another one. Okay. Just like all the previous problems, we need to run this into our graphing calculator and see if we can find one of our whole number solutions. And I've already done that. If you put it in your graphing calculator and look at the graph or look at the table to verify, one of your solutions is 2. So 2 goes in there. So 1, negative 2. This doesn't skip any, so I don't have to worry about that. Synthetic division, 1 comes down, 1. 1 times 2 is 2, that's 0. 0 and 2 is 0. 3 and 0 is 3, and 2 times 3 is 6, and that is 0 as well. Great. I ended up with 0, so everything's good. Now it started with an x to the third, so this will come down to an x squared. So I have x squared. Now there is no b term, so it's just x squared plus 3. Because I have a quadratic, I'm going to use quadratic formula to solve the rest of this problem, to figure out my other solutions. So, quadratic formula. X equals the opposite of b. Well, there is no b, so it's 0. Plus or minus the square root of b squared. Well, there is no b, so 0. Minus 4 times a times c. All over 2 times a. Now you're supposed to do the discriminant first, so you're supposed to do what's in here first. 0 minus 4 times 1 times 3 is negative 12. So I have 0 plus or minus the square root of negative 12 over 2. Now I don't need the 0 anymore. It's sort of pointless to have it there. But I do have a negative in the radical, so I'm going to take an I out and change that to a positive. And you could certainly leave the answer like this. Though if you want to simplify radical 12, it is 2 radical 3. So you could do or plus or minus 2i radical 3 over 2. Then the 2's would cancel, and you'd end up with plus or minus I radical 3. So I'm okay with either one. One's just not simplified, but you're not going to get counted wrong if you do this one either. So both of these would be valid. So on your graphing calculator, what you should have noticed when you put that into your graphing calculator, I should have 3 solutions. Because this power of 3 tells me I should have 3 solutions. So when you put it in your graphing calculator, you only see 1. There's only 1 time it crosses the x-axis. All that means is that I should have 3, but that only 1 is real. This is the only real solution because it was the only one that crossed the x-axis, which means that the other 2 must be imaginary, and they were plus or minus I radical 3. Now sometimes you don't need to go through all that trouble. Sometimes it's just like this. You could just, simply move the 1 over and get, one of your solutions that way. Like I don't necessarily have to put this in the graphing calculator. I could just move the 1 over and get x to the third equals 1, and then so the cube root of 1 is 1. So one of my solutions is x equals 1. So I could run 1 through synthetic division. It's got 1 for the third, but nothing for the x squared, nothing for the x, and negative 1. 1 comes down. It's 1. 1 times 1 is 1. 0 and 1 is 1. 1 times 1 is 1. 0 and 1 is 1. 1 times 1 is 1, and that is 0. So I'm left with, because it was an x to the third, this is going to be, wrong button, x squared. So I get x squared plus 1x plus 1. And that would go through the quadratic formula. And I'm just going to do this quickly because hopefully by now we understand how to use quadratic formula. But opposite of b plus or minus the square root of b squared minus 4 times a times c all over 2 times a. So you end up with negative 3 under the radical. So I get negative 1 plus or minus the square root of negative 3 over 2. That negative 3 becomes positive by putting an I out front. So I get the answer of negative 1 plus or minus I radical 3 over 2. So that is, so you can see it's exactly the same process we did in the last lesson, exactly the same thing. The only difference is you will see complex solutions. So on a test, you're not going to know which ones are complex and which ones are not, unless you know that when you put it in your graphing calculator, If you're supposed to have 3 and you only see 1, well, then you're going to have complex solutions. If you put it in your graphing calculator and you should have 4 and you see 3, then you're going to have complex solutions. But if you put it in your graphing calculator and you should have 3 and you see all 3, then there are no complex solutions. So the last thing here is, again, going backwards. All right, I talked about this last lesson in that you were going to see this again, and we would practice it again. How do we go backwards? How do we write a function given the solutions? So here you have a solution, and a solution. We start by putting it in factored form, which is putting it back in parentheses. You just have to remember that it's always opposite the signs of the solutions. And then all we do is multiply everything. So if you remember your skills in multiplying polynomials, you'll know that you can only do 2 at a time. So we sort of put a wall up. X times x is x squared. X times 3 is 3x. 0 times x is 0x. 0 times 3 is 0. These essentially cancel out, so I'm left with x squared plus 3x, and then I'm going to bring down this third term and repeat the process. X squared times x is x to the third. X squared times negative 4. 3x times x. 3x times negative 4 is negative 12x. Combine like terms. My final answer is x to the third minus 4. Oops. Not minus 4. Minus 1, x squared, and minus 12x. Now here's the only thing that we have to make sure. When you read the problem, we have to make sure that everything matches. So it says write a polynomial. Yep, got that. In standard form. Yep, got that. As a degree of 3. Yep, we sure do. It's a degree of 3. The zeros are that. Yep, that's how we figured this out. And a leading coefficient of 2. Well, there's where the problem is. I don't have a leading coefficient of 2, but I could just make my leading coefficient 2 by simply just multiplying everything by 2. So I get a final answer of 2x to the third minus 2x squared minus 24x. And that is how you go backwards once again. Now you certainly, if you want to try this one, you can. The solutions are written out for you right here. There's your solution, there's your solution, there's your solution. You just go backwards, put it in parentheses, and multiply it out. Same thing. And just make sure it matches. The only difference here is it gives you the y-intercept. The y-intercept in a polynomial is always the number that is by itself. So in this particular polynomial, there is no number by itself here, so the y-intercept is 0. But in any of these, and we can go up here too, so in here, the polynomial, the y-intercept would be negative 36. Here it would be negative 6, and here it would be negative 1. So the number that's by itself is always the y-intercept. So when you go and you multiply, when you multiply all these out, see what your y-intercept is. If it's 6, then great, because it's supposed to be 6. But if it's like 3, then you're going to need to make it 6. You would need to multiply everything by 2. And that is solving polynomials involving complex solutions. If you have any questions, please let me know.